One. Okay. Now we're going to talk about Lenz's law, which is really just a corollary to Faraday's law. And I want you to write this out into your notes with me. Okay. The induced current in a loop is in the direction that creates a magnetic field that opposes the change in magnetic flux through the area of the loop. Okay. Which is really exactly the same thing as Faraday's law. It's just said instead of you stating it in terms of EMF and voltage, it's stating in terms of the current. Okay, that the current that is induced is in the direction that creates a magnetic field that opposes the change in the flux through the area of the loop. It's structured almost exactly the same as Le Chatelier's principle. Okay, that a system at equilibrium will react in a way to oppose the change. It's the same idea. Okay, so we're going to draw this try and draw it and then put it in a little perspective here. Okay, so here's our loop, and we have the area of our loop here. And through our loop, we have a certain amount of magnetic flux. All right, so here's our magnetic flux through our loop. Imagine what it would take to change the flux in the loop. If we want to increase, then we have to squeeze more lines in there, right? Okay, we increase the field strength, and we would get more lines in there, right? Okay. Well, if we do that? If we increase the amount of flux in that direction, what's going to be the direction of our current? Okay, so for finger, it's going to go that way, right? Okay, so it'll go. Okay, I'm sorry. If we increase the amount of lines, okay, then to oppose the change, it's going to have to go the other direction, right?
So that's the current.
Okay, so what is going to make, if we have more lines going through here, the current is going to change to oppose this, which means we need right hand pointing down, right? Point through the loop. In the middle of the loop, we need our fingers pointing down, right? And so I'm going to turn this, and you're not going to be able to see this here's the loop, right? Here's the magnetic field pointing back towards me. Here's the loop. To oppose the change, our fingers go in that direction inside the loop, right? Not outside the loop, inside the loop. Because we need to oppose the change inside the loop. If we're increasing this direction, our finger's pointing the other direction. Wrap around the current, and it goes in that direction. Right? So to me, that's clockwise. To you guys, that's counterclockwise. Right? We're on opposite sides of the loop. Okay, if I'm behind the clock face, to me it's clockwise. You guys following that? Okay. So this is where our E equals negative d phi dt comes in. This is where the negative comes in. Okay, that's Lenz's law, and I'm telling you guys, the only way that you're going to get it is by practicing it. And it's just like, and you need to practice it the same way you practice Le Chatelier. You just have to try it. You just need to try it and keep working with it.
You just put your hand into the loop and then you
Grab the wire.
the wire, keep walking, grab it the other way. How do you know which way?
Your fingers are in the opposite direction of the change of your flux inside the loop.
Oh,
So for this loop, your fingers are going down inside the loop. You grip, but then you're going to go that direction. Okay, so you would go that way. You're changing the direction of your loop. Okay, so here's Lenz. This is Lenz's law. We're going to stop it here, and the way we get it is with more practice. So we'll do that.